Hello students, we are solving a question on magnetism. This is from 24th January, shift to JEE Mains 2026. The question says, two identical circular loops P and Q, each of radius small r, are lying in parallel planes such that they have a common axis. The current through P and Q are I and 4I respectively in clockwise direction as seen from O. The magnetic field, net magnetic field at O is. So, let us draw an observer at O. There are two observers, one looking towards Q and one looking towards P. And both of them see clockwise current with respect to themselves. With respect to Q, if you apply right hand thumb rule, at point O, Q will be generating a net magnetic field to the right according to right hand thumb rule. Similarly, if you will apply right hand thumb rule to P with respect to O, it will be generating a magnetic field to the left. Although to the observers at O, the current in the loop P and Q appear to be clockwise. Since they are looking in opposite direction, the same direction magnetic field will produce opposite direction magnetic field at point O. I mean, the same direction current, clockwise current, with respect to the Q loop will produce a rightward field at point O. Similarly, clockwise current in P with respect to point O will produce a leftward magnetic field. Thus, the magnetic field at point O are opposing each other with respect to the loop P and Q. The magnetic field on the axis of a current carrying loop is given by the expression mu naught I r square divided by r square plus x square whole to the power of 3 by 2, where r is the radius of the loop and x is the distance of the point from the center of the loop, right? Distance of point O basically in this case, which is also luckily given to be equal to the radius of the loop. So now, if we calculate the net magnetic field, it's equal to magnetic field due to P loop minus magnetic field due to Q loop. Now the current in P loop is 4I, substituting that, and the x or the distance of point O from the center of P loop is small r itself. Similarly, the current in Q loop is I, and its distance from the center of the Q loop of point O is also r. Substituting these values and calculating, you're going to end up with 3 mu naught I divided by 2 root 2 r. And of course, since the magnetic field of P is greater than magnetic field of Q, because the current in P is greater than current in Q, the net magnetic field will be towards point P. So our option 1 is correct.